So, what are the types of machine learning? We have three, no? I think na-discuss na natin to before, no? The supervised, unsupervised, and reinforcement. When we say supervised learning, a type of learning, type of machine learning where the model is trained on a labeled dataset. For example, you are predicting house price based on their features like size, location, and amenities. For example, yung cats, ano ba yung mga features ng cats? So yung mata nila, yung nose nila, yung tenga nila. So that you call labeled dataset. Yung dog, no? Papakita mo sa machine kung ano-ano ba itsura, yung features na meron ng dog, no? That's supervised learning, no? Where the model is trained on a labeled dataset. Ngayon, kung ang puro pinapakita mo sa kanya is labeled na dog, no? Same features, no? And then biglang papasok, maglalagay ka ng itsura ng ibon. Hindi niya malalaman 'yun. Kasi ang nai-train lang sa kanya yung labeled dataset na dog na merong ganitong mga feature, mahabang ilong, yung tenga, 'di ba? Yung size niya, yung color niya. So that's supervised learning. How about unsupervised learning? Ano naman ito? So involves training a model on an unlabeled dataset, allowing it to find patterns and relationships on its own. For example, clustering similar customer preferences in e-commerce. That's unsupervised learning. The next one is reinforced learning or reinforcement learning. So learning through trial and error. Okay, ganyan lang yon. Yan yung keyword mo. No? Learning through trial and error, where the model receives feedback in the form of rewards or penalties. For example, training computer program to play and win games. So for example, sa chess, 'di ba? Yung ano na 'yan? Yung kay Gary Kasparov, 'di ba? That's example of reinforcement learning. It learned through trial and error, where the model receives again rewards for the job well done and penalties for every wrong na nagagawa niya. So that's reinforcement learning. To understand more about machine learning, let us again watch the following videos that I have prepared for you. Okay?
Artificial intelligence and machine learning. What's the difference? Are they the same? Well, some people kind of frame the question this way. It's AI versus ML. Is that the right way to think of this? Or is it AI equals ML? Or is it AI is somehow something different than ML? So here's three equations. I wonder which one is going to be right. Well, let's talk about this. First of all, when we talk about AI, I think it's important to come with definitions because a lot of people have different ideas of what this is. So I'm going to assert the simple definition that AI is basically exceeding or matching the capabilities of a human. So we're trying to match the intelligence, whatever that means, and capabilities of a human subject. Now, what could that involve? There's a number of different things. For instance, one of them is the ability to discover, to find out new information. Another is the ability to infer, to read in information from other sources that maybe has not been explicitly stated. And then also the ability to reason, the ability to figure things out. I put this and this together and I come up with something else. So I'm going to suggest to you this is what AI is, and that's the definition we'll use for this discussion. Now, what kinds of things then would be involved if we were talking about doing machine learning? Well, machine learning, I'm going to put that over here, is basically a capability. We'll start with a Venn diagram. Machine learning involves predictions or decisions based on data. Think about this as a very sophisticated form of statistical analysis. It's looking for predictions based upon information that we have. So the more we feed into the system, the more it's able to give us accurate predictions and decisions based upon that data. It's something that learns, that's the L part, rather than having to be programmed. When we program a system, I have to come up with all the code, and if I want it to do something different, I have to go change the code and then get a different outcome. In the machine learning situation, what I'm doing could be adjusting some models, but it's different than programming. And mostly it's learning the more data that I give to it. So it's based on large amounts of information. And there's a couple of different fields within, a couple of different types. There is supervised machine learning and, as you might guess, there's an unsupervised machine learning. And the main difference, as the name implies, is one has more human oversight, looking at the training of the data, using labels that are superimposed on the data. Unsupervised is kind of able to run more and find things that were not explicitly stated. Okay, so that's machine learning. It turns out that there's a subfield of machine learning that we call deep learning. And what is deep learning? Well, this involves things like neural networks. Neural networks involve nodes and statistical relationships between those nodes to model the way that our minds work. And it's called deep because we're doing multiple layers of those neural networks. Now, the interesting thing about deep learning is we can end up with some very interesting insights, but we might not always be able to tell how the system came up with that. It doesn't always show its work fully. So we could end up with some really interesting information, not know in some cases how reliable that is because we don't know exactly how it was derived. But it's still a very important part of all of this realm that we're dealing with. So those are two areas, and you can see DL is a subset of ML, but what about artificial intelligence? Where does that fit in the Venn diagram? And I'm going to suggest to you it is the superset of ML, DL, and a bunch of other things. What could the other things be? Well, we can involve things like natural language processing. It could be vision. So we want a system that's able to see. We might even want a system that's able to hear and be able to distinguish what it's hearing and what it's seeing, because after all, humans are able to do that. And that's part of what our brains do, is distinguish those kinds of things. It can involve other things like the ability to do text to speech. So if we take written words, concepts, and be able to speak those out. So this first one involved being able to see things. This is now being able to speak those things as well. And then other things that humans are able to do naturally that we often take for granted is motion. This is the field of robotics, which is a subset of AI. The ability to just do simple things like tie our shoes, open and close the door, lift something, walk somewhere. That's all something that would be part of human capabilities and involves certain sorts of perceptions, calculations that we do in our brains that we don't even think about. So here's what it comes down to. It's a Venn diagram, and we've got machine learning, we've got deep learning, and we've got AI. So I'm going to suggest to you the right way to think about this is not these equations. Those are not the way to look at it. In fact, what we should think about this as machine learning is a subset of AI. And that's how we need to think about this. When I'm doing machine learning, in fact, I am doing AI. When I'm doing these other things, I'm doing AI. But none of them are all of AI, but they're a very important part. Thanks for watching. Please remember to like this video and subscribe to this channel so we can continue to bring you content.
Supervised and unsupervised learning are two core components in building machine learning models. So, what's the difference? Well, just to cut to the chase, supervised learning, that uses labeled input and output data, while an unsupervised learning model doesn't. But what does that really mean? Well, let's better define both learning models, go deeper into the differences between them, and then answer the question of which is best for you. Now, in supervised learning, the machine learning algorithm is trained on a labeled data set. So this means that each example in the training data set, the algorithm knows what the correct output is. And the algorithm uses this knowledge to try to generalize to new examples that it's never seen before. Now, using labeled inputs and outputs, the model can measure its accuracy and learn over time. Supervised learning can be actually divided into a couple of subcategories. Firstly, there is a category of classification. And classification talks about where the output is a discrete class label, such as spam and not spam. Linear classifiers support vector machines, or SVMs, decision trees and random forest. They're all common examples of classification algorithms. The other example is regression. The output here is a continuous value such as price or probability. Linear regression and logistic regression are two common types of regression algorithms. Now, unsupervised learning is where the machine learning algorithm is not really given any labels at all. And these algorithms discover hidden patterns in data without the need for human intervention. They're unsupervised. Unsupervised learning models are used for three main tasks. There's clustering, association, and dimensionality reduction. So let's take a look at each one of those, starting with clustering. Now, clustering is where the algorithm groups similar experiences together. So a common application of clustering is customer segmentation, where businesses might group customers together based on similarities like, I don't know, age or location or spending habits, something like that. Then you have association. And association is where the algorithm looks for relationships between variables in the data. Now, association rules are often used in market basket analysis, where businesses want to know which items are often bought together. Something along the lines of customers who bought this item also bought, that sort of thing. The final one to talk about is dimensional reduction. And this is where the algorithm reduces the number of variables in the data while still preserving as much of the information as possible. Now, often this technique is used in the pre-processing data stage, such as when autoencoders remove noise from visual images to improve picture quality. Okay, so let's talk about the differences between these two types of learning. And in supervised learning, the algorithm learns from training data sets by iteratively making predictions on the data and then adjusting for the correct answer. While supervised learning models tend to be more accurate than unsupervised learning models, they do require all of this upfront human intervention to label the data appropriately. For example, a supervised learning model can predict how long your commute will be on the time of day and thinking about the weather conditions and so forth. But first you'll have to train it to know things like rainy weather extends the driving time. By contrast, unsupervised learning models work on their own to discover the inherent structure of unlabeled data. These models don't need humans to intervene. They can automatically find patterns in data and group them together. So, for example, an unsupervised learning model can cluster images by the objects they contain, things like people and animals and buildings, without being told what those objects were ahead of time. Now, an important distinction to make is that unsupervised learning models don't make predictions. They only group data together. So if you were to use an unsupervised learning model on that same commute data set, it would group together commutes with similar conditions like the time of day and the weather, but it wouldn't be able to predict how long each commute would take. Okay, so which of these two options is right for you? In general, supervised learning is more commonly used than unsupervised learning, and that's really because it's more accurate and efficient. But that being said, unsupervised learning has its own advantages. There's two that I can think of. Firstly, unsupervised learning can be used on data that is not labeled, which is often the case in real-world data sets. And then secondly, unsupervised learning can be used to find hidden patterns in data that supervised learning models just wouldn't find. Classifying big data can be a real challenge in supervised learning, but the results are highly accurate and trustworthy. And in contrast, unsupervised learning can handle large volumes of data in real time. But there's a lack of transparency into how that data is clustered and a higher risk of inaccurate results. But wait, it is not an either-or choice. May I present to you the middle ground known as semi-supervised learning. This is, well, a happy medium where you use a training data set with both labeled and unlabeled data. And it's particularly useful when it's difficult to extract relevant features from data and when you have a high volume of data. So, for example, you could use a semi-supervised learning algorithm on a data set with millions of images where only a few thousand of those images are actually labeled. Semi-supervised learning is ideal for medical images where a small amount of training data can lead to a significant improvement in accuracy. For example, a radiologist can look at and label some small subset of CT scans for tumors or diseases, and then the machine can more accurately predict which patients might require more medical attention without going through it and labeling the entire set. Machine learning models are a powerful way to gain the data insights that improve our world. The right model for your data depends on the type of data that you have and what you want to do with it. And the choice between supervised and unsupervised learning is only the first step. If you have any questions, please drop us a line below. And if you want to see more videos like this in the future, look, fair warning, if you're feeling a little hungry right now, you might want to pause this video and grab a snack before continuing, because I'm going to explain the difference between machine learning and deep learning by talking about pizza. Delicious, tasty pizza. Now, before we get to that, let's address the fundamental question here. What is the difference between these two terms? Well, put simply, deep learning is a subset of machine learning. Actually, the hierarchy goes like this. At the top, we have AI, or artificial intelligence. Now, a subfield of AI is ML, or machine learning. Beneath that, then we have NN, or neural networks, and they make up the backbone of deep learning algorithms, DL. And here on the IBM Technology channel, we have a whole bunch of videos on these topics. You might want to consider subscribing. Now, machine learning algorithms leverage structured, labeled data to make predictions. So let's build one, a model to determine whether we should order pizza for dinner. There are three main factors that influence that decision, so let's map those out as inputs. The first of those inputs we'll call X1. And X1 asks, will it save time by ordering out? We can say yes with a 1 or no with a 0. Yes, it will, so X, that equals 1. Now X2, that input says, will I lose weight by ordering pizza? That's a 0. I'm ordering all the toppings. And X3, will it save me money? Actually, I have a coupon for a free pizza today, so that's a 1. Now, look, these binary responses, 1s and 0s, I'm using them for simplicity, but neurons in a network can represent values from, well, everything to everything, negative infinity to positive infinity. With our inputs defined, we can assign weights to determine importance. Larger weights make a single input's contribution to the output more significant compared to other inputs. Now, my threshold here is 5. So let's weight each one of these. W1, well, I'm going to give this a full 5 because I value my time. W2, this was the will I lose weight one. I'm going to rate this a 3 because I have some interest in keeping in shape. And for W3, I'm going to give this a 2 because either way, this isn't going to break the bank to order dinner. Now, we plug these weights into our model, and using an activation function, we can calculate the output, which in this case is the decision to order pizza or not. So to calculate that, we're going to calculate the y hat, and we're going to use these weights and these inputs. So here we've got 1 times 5, we've got 0 times 3, and we've got 1 times 2. And we need to consider as well our threshold, which was 5. So that gives us, if we just add these up, 1 times 5, that's 5, plus 0 times 3, that's 0, plus 1 times 2, that's 2, minus 5. Well, that gives us a total of positive 2. And because the output is a positive number, this correlates to pizza night. Okay, so that's machine learning, but what differentiates deep learning? Well, the answer to that is more than 3. as in, a neural network is considered a deep neural network if it consists of more than 3 layers, and that includes the input and the output layer. So we've got our input and output. We have multiple layers in the middle, and this would be considered a deep learning network. Classical machine learning is more dependent on human intervention to learn. Human experts, well, they determine a hierarchy of features to understand the differences between data inputs. So if I showed you a series of images of different types of fast food, like pizza, burger, and taco, you could label these in a data set for processing by the neural network. A human expert here has determined the characteristics which distinguish each picture as the specific fast food type. So for example, it might be the bread of each food type might be a distinguishing feature across each picture. Now this is known as supervised learning because the process incorporates human intervention or human supervision. Deep machine learning doesn't necessarily require a labeled data set. It can ingest unstructured data in its raw form, like text and images, and it can automatically determine the set of features which distinguish pizza, burger, and taco from one another. By observing patterns in the data, a deep learning model can cluster inputs appropriately. These algorithms discover hidden patterns of data groupings without the need for human intervention, and they're known as unsupervised learning. Most deep neural networks are feed-forward. That means that they go in one direction, from the input to the output. However, you can also train your model through something called backpropagation. That is, it moves in the opposite direction from output to input. Backpropagation allows us to calculate and attribute the error associated with each neuron and allows us to adjust and fit the algorithm appropriately. So when we talk about machine learning and deep learning, we're essentially talking about the same field of study. Neural networks, they're the foundation of both types of learning, and both are considered subfields of AI. The main distinction between the two are the number of layers in a neural network, more than 3, and whether or not human intervention is required to label data. Pizza, burgers, tacos, yeah, that's enough for today. It's time for lunch. And before I go, if you did enjoy this video, here are some others you might also like. If you have any questions, please drop us a line below.
Okay, so let us continue on the discussion of the importance of machine learning, no? And giving you some examples of machine learning. Okay, so we have here predictive analytics. So ito ang importansya ng machine learning because of the predictive analytics. So predictive analytics leverages machine learning to analyze historical data and forecast future trends or outcomes. So dito, for example, in finance, predicting market trends and optimizing investment portfolios based on historical performance. So si machine learning, inaaral niya yung previous data or historical data and can formulate or forecast a future trends or outcomes. So that's machine learning using, that's predictive analytics using machine learning. Next one is personalization. So here, machine learning enables the customization of user experience by understanding individual preferences and behavior. Dito yung naalala nyo kanina, yung recommendation system, ano? So, social media platforms utilizing ML algorithms to curate personalized content feeds based on user interactions. So, nakadepende yung ipapakit sa'yo ng social media platforms, nakadepende yun sa perspective mo, sa user habits mo, no? So doon bibigyan ka ni machine learning ng mga customized user experience. Okay? So that's personalization using machine learning. The third one is fraud detection. When we say fraud detection, machine learning algorithms analyze patterns in data to detect anomalies and identify potential fraudulent activities. For example, no, banking systems flagging unusual transactions and alerting customers to potential fraudulent activities. So dito, inaaral ng machine learning algorithms yung mga pattern. If there's something if there's something unusual, or they detect some anomalies within the banking system, they can flag it as fraudulent activities. So that's how machine learning is used in fraud detection, especially in finance. Okay? The fourth one is healthcare diagnostics. So dito, machine learning aids in analyzing medical data. Okay? Especially for disease detection, diagnostics, and personalized treatment plans. So identifying patterns in medical imaging data to assist in the early detection of diseases like cancer. So dito, for example, gagamit si machine learning or yung platform mo ng images or medical data that they could detect and diagnose the patterns in relation to your disease. For example, na meron silang nakitang pattern na somehow uh, related or malapit sa cancer, then they could easily diagnose you and give you personalized treatment plans. Ver- uh, 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 that could help you, no, to cure your disease. Okay, so that's healthcare diagnostics using machine learning. And the last one is optimizing operations. So dito, no, machine learning is applied to streamline and optimize operational processes by analyzing data and identifying efficiencies. For example, no, sa supply chain natin, no, supply chain optimization through predictive maintenance, reducing downtime, and improving overall efficiency. No? Ang ginagawa ng machine learning dito, inaagapan niya na kaagad through predictive maintenance. No? And also, it could predict some equipment failures based on the previous maintenance. No? Depende sa mga downtime na meron ang isang operations. No? So that's how machine learning could apply is and used in manufacturing or in any operations that involve analyzing of data. Okay, so those are the importance of machine learning. They could help in predictive analytics, personalization, fraud detection, healthcare diagnostics, and optimizing operations. So here are some of the programming languages for machine learnings. Okay, so Python, R, Java, and C++. No, so I will not dig deep on how we can use this. So those are or these are some of the programming languages that if you want to pursue machine learning, no. Okay. Again, Python, R, Java, and C++.